Okay, so once we're ready to begin our experiment, we'll have our goggles on our faces to protect them. And we're going to take our 3 samples of water that we're going to test. And for a moment, I'm just going to back up. Earlier in the year, we learned about different types of variables. And so I'm just going to review those with you now so we have a recollection of what those mean and what they are. So we have the independent variable, the dependent variable, and then our control. So we have our 3 water samples. They're going to be at equal volumes, and there's going to be an equal amount of soap deposited in each test tube. So what's going to be the independent variable is the thing that we control, what we can change about the experiment, and that's the amount of soap that we add. So even though it's equal, we're the ones that are actually changing, or we can control how much soap is added to each. So we can just define that quickly. In this case, it's the soap. In other experiments, it'll be something different. And then what changes as a result of how much soap we add is the amount of suds that are produced. So the dependent variable changes as a result of the independent variable. Changes as a result of independent variable.
Should we write this down?
You'll have a time to copy it down, yeah. Or if you have your notebooks out, you can copy it now. So you have that reference for later. Thank you, Javon. And then your control is what you're, a sample that you're comparing the other samples to. So in this case, it's going to be water that I have intentionally made hard by adding calcium ions into it using calcium chloride. So it's the so having this written down would be a good idea so you can refer to it later. Okay, and you'll follow this in your procedure, but you're gonna have your 3 water samples. You're gonna have your tap water. So this is Roselle water. You'll have your control, which is your hard water, and your distilled water, which contains no ions or very little ions. I was unable to get deionized water, which contains no ions, but this is the next best thing. So I would just recommend labeling each of your test tubes. Some of them have a white marker on the side, which you can write on. These don't. So I'm just going to take 3 small pieces of tape just to label, not label 1, 2, 3, but label as, town water, control water, or distilled water. So you can use tape so you can easily remove it later. Okay, so each one, you want to do this before you add the water, So you want to spill it? Okay. So each test tube is going to get 20 milliliters of each sample. So I'm just going to label my test tubes. This is town. The benefit of having multiple people in a group is you can share these duties. So one person can be handling the samples, another person can be handling the test tubes, another person can be recording. This is our control. And then our distilled. Okay, so you're gonna pour, and we remember how to read eye level, right? We come down to the level of the beaker where we see the water intersecting the lines. This is right at 50 milliliters, so we're gonna pour 20 milliliters into each tube. It doesn't have to be exact as long as they're about the same level, but just so you have an idea, it's about 20. I'll read this again. So you want it about halfway full. So if you have this rack, it's about the level up to the rack, the test tube rack. And so since I already measured one, I'm just gonna compare the others to that height, so I know it's about 20. Just real quick, let's define these items. This is a beaker. This is, I think this is our first time using a test tube. It's a test tube. And this is a test tube rack. Okay, so now we're adding 2 to 3 drops of soap in each test tube. Try to do the same. So if you're gonna do 2, do 2 for each. If you're gonna do 3, do 3 for each. And so you'll add, and you try to be precise. Try to, that's 1, 2, 1, 2, 1, 2. And so this is where it gets interesting, because you can divvy up the responsibilities, between each, the 3 people in your group. So each person can take one test tube and vigorously shake until you see suds. So it's probably gonna be about 10 seconds. There's sinks over there in case there's a spill. There's paper towels nearby. And so you're shaking because you want to produce as much suds as possible, right? It's a good thing. And so you're shaking. 1, 2, I'm already spilling a little bit. You try to contain as much as you can. All right, it's about 10 seconds. So immediately after shaking, you want to use some type of measuring tool. This is a little large, but to see how, at what height the suds are. And so this is 5 centimeters, so you just want to record that, so you're going to record immediately after shaking and then 2 minutes later. And so while you're doing the one, another of your group mates can be doing another one, shaking. So the first one was the town water, the second one is the control. And again, we measure. And so you should be making predictions as to what you think will happen. That's your hypothesis. So this is 3 centimeters. So you can already see the difference in height of the suds, right? This one is pretty near the top. And your third one, you should give it a good shake. And since it is only water, it's okay if it spills a little, but we just have to clean it up. And so lastly, you measured, and you want these quantitative measurements so you can get a good reading. Okay, and this one is 7 centimeters, so we got 5, 3, and 7. So you'll record that in your measurements. 2 minutes later, you'll then record again.